Right, so we'll have a look at an introduction into Pandas. So we'll just get logged in to our virtual machine. And there we go. Okay, so what you should find is there is a folder called datasets, and in there is a number of CSV files. So Pandas is good for reading in these CSV files and then to be able to parse into different columns. And it makes it easier for us to analyze our data. Okay, so let's pull up our tutorial. Okay, so if you go to asecuritysite.com/bigdata, and the tutorial should be here. Okay, so we'll just move that to the side there. And you should be able to copy and paste from within inside the VM. So the first thing that we're going to do is we're going to actually copy our code here, and so I'll just create a file called build.py just now, and we'll just paste that in. Okay, so sometimes the paste doesn't come in quite correct from the PDF, but just make sure that you get the new lines lined up. Okay, so what we'll do is we'll read in the CSV file, and so in this case it's within the datasets folder. Okay, and then we'll just view the first 3 records within the file. So you press Ctrl X, press Y for yes, and then save in the file name. Okay, so then we just go ahead and we'll just run it. Okay, so I've just used the wrong name for the datasets there. Okay, so we'll just bring that back, and it should be datasets. Okay, so then we'll go ahead and there we go. Okay, so we want to be able to print that out. So we'll just say print, and do that again, and there we go. Okay, so in this data set, there's the first 3 rows. There's the region, state, infant mortality rate, heart disease, stroke, suicide, and so on. Okay, so the next thing we're going to do is we're going to look at the actual data types in each of our columns. So the column property is .column, and we can look at the length of our we can look at the number of records that we've got using the len method. So we'll just open that back up. Okay, so we'll just print the length of version, and we'll print ver.columns, and just to save time we'll print len ver.datatypes. Okay, so this is going to give us the names of the columns, because it's that we'll actually use to be able to access our data. And then we've got ver.dtypes for our data type. Okay, so we'll just go with that, and then we'll just run that again, and there we go. Okay, so we have 51 records. 51 records from there. There we go, 51. And then this defines the names of our columns. Okay, so we put them in inverted commas because we might have spaces in there. So those are the names that we need to remember and use again. And then when we look at each of the parameters, we can see this one is an integer, this one's an integer here, and these ones are floating point values. Okay, so the next thing that we'll do is that we'll have a look at certain columns. So we can print for the infant mortality rate and the region state. So let's do that. Okay, so we use the square brackets to identify our data set, and we have region state. And we'll do the same again. This time we'll do it for infant mortality rate. Infant mortality rate. Okay, we'll save that and let's have a look. And there it's there. Okay, so each one has a certain index value, and then in this case this is the region state, and then this is our values for our infant mortality. Okay, so we can bring values together by putting a comma between each of the values that we're going to plot, and then putting them both in square brackets. So what we'll do is we'll print out the region state, the infant mortality rate, and heart disease. Okay. It's not copied it, so let's try again. Okay, so there we go. So we can actually plot, so in this case there's the region state. So Alabama has a mortality rate of 8.6 and a heart disease rate of 224. You can see Alaska, lower infant mortality and lower heart disease. Okay, so now what we can do is we can actually use the describe method to be able to look at means and averages, minimum, maximum. Okay, so that's just .describe. And then what we'll do is we'll just we'll also do the next part, which is a sort. And while we're at it, we'll just do a reverse sort. Right, so let's just type that in. Okay, so each method has values that we pass into it, and it's a free format, so we can actually type in the parameter here and then define. By default it's ascending order, so if we make it ascending equals false, then it'll do in descending order. Okay, in Python false is a capital F. Okay. Okay, so that's done the describe. So the describe gives us there's the count, 51 values, there's the mean for infant mortality rate, minimum, maximum, standard deviation, and so on. Okay, and we just got a little problem on one of the properties there. Okay, so just let's check. So it's infant mortality rate looks fine. Hit 3, that's okay. And there's them. Okay, so that allows us to be able to look at our different values there. We can sort in terms of a certain parameter. In this case we're sorting in terms of the mortality rate. We can see here that Mississippi has the top mortality rate, and the lowest one is, I think it's 4.2. There it's that. Iowa, Massachusetts tie equally for the lowest mortality rate. Okay, so a really powerful method that we can have is what's called correlation. So the correlation will actually go in and correlate each of the parameters against each other. So we'll just get rid of that. And we'll look for a correlation. So there we go. So what we're looking for is the big values, the big negative values or big positive values. Something around 1, between 0.7 and 0.9 is quite significant. So in this case we can actually see here that the infant mortality rate, the cancer death rate, as we would expect, has a strong correlation to the smoking deaths per 100k of the population. There's another strong one. So heart disease is strongly correlated, fairly strongly correlated to cancer death rate. But when we look, we'll see other ones that are not quite as correlated. Stroke rate doesn't really correlate that much with unemployment, and so on. So you find there's ones wherever there's the same value in each column. Okay, so we look for strong correlations and weak ones, and if we want we can correlate just two values together, and see if we can copy and paste that. So there. Okay, so we'll call it the infant mortality rate with heart disease death rate. Okay, because we use multiple parameters, we've got the double square brackets there, and then we apply correlation there. Just let's check, that's fine. And there we go. Okay, so that allows us just to, you can see there's quite a high correlation there between the heart disease and infant mortality rate. Okay, and then we can look at the covariance. That gives us the significance. So we just change that to COR there. Now what we'll do is we'll actually analyze and search for values. Okay, so in this case what we're going to do is look for our infant mortality rate greater than 4.8. Let's try and catch it again. Oops. There we go. So it's given us true and false values if that's the case. Okay, so we can do the same and actually list the whole data set if we define it like this. So that's actually taking the whole of the data set and then filtering for an infant mortality of greater than 7. Okay, there we go. Okay, so that's allowed us to look at our data set and purely look at the infant mortality rate greater than 7. It's a bit difficult to see it from there, but it's actually there. Okay, so those are the states which have a mortality rate greater than 7. And then the good thing now is that because we've printed the whole of the object out, it's actually shown us all the other parameters. Okay, and we can use and or operators if we want. The next thing we'll do is we'll look to fit a linear regression onto it if there is a linear relationship. So it's not always the case that we have a linear relationship, but I think we have with inside infant mortality rate and heart disease death rate. So we should be able to find what the linear equation is for the fit between the two. Okay, so we're going to import this library here, stats model. And it's going to fit using linear regression for infant mortality rate and heart disease. Okay, so normally we put the imported libraries at the top, but we'll just put them in there just now. So just get rid of that line there. And there we go. Okay, so that means that that the fit is fairly good. 0.982 is a fairly good fit for our R-squared value, and then the actual equation. Okay, so now let's do a little bit of our linear regression. So with this we'll use NumPy, and NumPy allows us to do a polynomial fit. In this case it's just for a linear equation. So that will give us m, which is the gradient, and b is the point at which it cuts the y-axis. Okay, so we can fit our two data sets there. So the infant mortality rate is the x, and heart disease death rate is the y. And then what we'll do is we'll just print out heart disease is equal to the gradient times the mortality rate plus the point at which it cuts the y-axis. Okay, so when we run that, it gives us that heart disease death rate is equal to 17.027 times the mortality rate plus 63.72. Okay, so that gives us a quick overview of our introduction to pandas.